Today I wanted to talk about the engineer's role in during the life cycle of an aircraft. When I talk about engineers, I'm referring to not the maintenance engineers who actually put their hands on the aircraft, but the engineers who do the functions of designing the aircraft, building the aircraft, testing the aircraft, analyzing the data, and so on for the aircraft. During the life cycle starts with the obviously the conceptual design of the aircraft, where the requirements from the manufacturers, the customers, um, the clients, the operators, um, the regulators are considered, and the aircraft is designed to perform to those to meet those requirements. If the aircraft is going to be a long haul aircraft, if it's going to be short hops, the size of the aircraft, the amount of passengers, the distance is going to fly, and so on. So these things are considered by the aircraft designers. They take those requirements and they do trade studies to determine what type of systems they'll be in the aircraft, and then they come up with a eventual design of the aircraft. The aircraft is then tested. It's built. Sorry, the test aircraft is built, it's flown, it's flight tested, and so on, and the results are analyzed. And these are all done by different types of engineers. Aerospace engineers, mechanical engineers, electronics engineers, software engineers design the software that go on the avionics and so on, and also the engineers who design the infrastructure that actually support the aircraft while it's being built. There's civil engineers who are involved, industrial engineers who are involved in different aspects of the creation of the aircraft. Then, as I mentioned, the aircraft is flown, is tested. The parameters are looked at, analyzed by the engineers, who then, there are ultimately trade-offs during the testing. Sometimes testing doesn't go as planned. Sometimes it goes as better as planned. The designs may be changed. Things may be updated. Perhaps even the vendors who are making components for the aircraft, some electrical components, sometimes they may change their designs, and then the overall design of the aircraft has to be changed to accommodate that, to be able to meet the safety requirements and the performance requirements of the ultimate aircraft. Then, of course, when it reaches a certain point throughout the process, the regulators are involved. They're the ones who review the aircraft design and the analysis and the test results to determine if the aircraft meets the safety requirements specified in the civil aviation regulations. They're involved usually early in the process, working with the manufacturers to make sure that their testing and so on, the results from the testing will be able to show that the aircraft and the way it performs and the safety features and so on do meet the regulations for the aircraft to be operated in a safe manner. Then, of course, as when the aircraft is ultimately certified by the regulatory authority, then the aircraft is operated by the operator, either in commercial service or can be even in private service. But it's operated, and during the operation, things change. The aircraft gets older, new technology comes along. The operator may want to incorporate new technology, so there are engineers involved in assessing design changes, after the aircraft is in service, and incorporating, newer things like heads-up displays or maybe a new avionics suite. But the engineering has to be done to be able to allow those newer systems to be incorporated into the older aircraft, and while still maintaining or improving the level of safety of the aircraft. And of course, while that's being done, the aircraft is still accumulating hours, and there's wear and tear on the aircraft, which has to be assessed, and that's typically done by the inspectors and the maintenance engineers, the ones who are certificated to do the repairs on the aircraft and so on. But it may come to a point where repairs that need to be done on the aircraft after it's been in service weren't some aspects of them weren't considered when the aircraft was being designed. If the aircraft is a 15-year-old aircraft, maybe there are new repairs that are weren't considered in the original design that have to be developed by engineers who work for third-party companies. Those guys who actually can work with aircraft that have been in service for a while, and they know a little bit more about the aircraft operation than the manufacturers. For example, the aircraft operators, they work with these third-party facilities and sometimes with the manufacturers to develop repairs for certain things. Like, for example, if a baggage conveyor belt, for example, hits the aircraft in a certain location, just because maybe as accidents happen, and they may want to develop, engineers have to develop a repair for that specific section or a specific area of the aircraft that maybe wasn't originally designed to be repaired, or wasn't considered in the original design on how to repair it. Then that would have to be assessed by engineers who would come up with a design and get it approved and so on before it can be incorporated. So there are many engineers, and this goes on throughout the life of the aircraft, as different engineers look at the performance and are able to take into consideration changes in the aircraft performance, changes in technology, changes in how the owners may want to operate the aircraft to make it more efficient for their specific type of operation. If they're doing short hops or if they're doing longer legs and so on, the aircraft will deteriorate in different ways. Specifically, the engines will deteriorate in different ways, and as a result, there may have to be changes in the maintenance procedures, in the maintenance intervals for those components. And it takes engineers to do the engineering evaluation of the components of the newer technology that may want to be that the owners may want to incorporate into their aircraft, to get longer life, to get better performance, and so on. So throughout the life cycle, these things have to be considered and evaluated properly, by trained professionals who are the engineers who support the aircraft in the industry throughout its life cycle. And then there comes a point where the aircraft itself may reach the end of its life cycle, but there are parts on the aircraft that still have value and still have life remaining in them. So those parts can be removed from the aircraft once the aircraft has reached its different limitations, and the owners make an assessment, say that, okay, yes, according to the original design of the aircraft was designed originally to last this many cycles, this many hours, and certain parts on the aircraft have deteriorated beyond economical repair, or the aircraft is no longer, the aircraft as a whole it's not worth it financially to make the aircraft airworthy again. Parts can be removed from the aircraft and then refurbished or continued in operation on other aircraft, depending on the part and its criticality and so on, and how it was maintained. So these engineers are also involved in evaluating those parts as well, just to be able to continue to save money for other operators of similar aircraft, being able to change parts and so on, have parts being available. It also requires an engineering evaluation. So as a result, you can see that in the aircraft industry, engineering is critical in many different areas, some of which I just described, but also in many other areas as well. So there are, we've tried to explore some of these other areas and some other ways that not only engineers but also people involved in aviation in different capacities help to continue to make aviation safe and the most economical and the best way to travel, quite frankly. So I hope you continue to follow my channel, and hope you're able to learn a little bit more about aviation infrastructure, and how the aviation professionals out there continue to make aviation the safest form of transportation in the world. Take care.